Hello everyone. Today's workshop instructor is Jill Rumore, a biologist and a PhD candidate who is also the workshop's co-coordinator. Jill will teach us on how to create, install, update, and remove Conda, as well as how to share Conda environments and how to run a package. Take it away, Jill.
All right, thanks for the introduction, Grace. So as Grace mentioned, today's workshop is going to focus on all things Conda. Now, I just want to note that a few of the slides have been updated since they were sent out yesterday, and the most recent version is available on the workshop GitHub. The link is available in the email that was sent out to participants with the workshop materials, but rest assured, the updates will not impact your ability to follow along with today's workshop. So before we get started, I just want to remind participants that all workshops are being recorded and will be posted to the MMID Coding Workshop YouTube channel. And due to time constraints and to ensure a smooth delivery of the workshop materials, we ask that you please hold your questions until the question and answer period, which will take place at the end of the workshop, and it will not be recorded. So today's workshop will focus on a number of learning objectives, including developing a basic understanding of Conda, navigating and creating Conda environments, finding packages and installing them, and then as an added bonus, I'm going to show you how to approach running a package in Conda. So what is Conda? Well, it's an open source package and environment management system that runs on Windows, Mac, and Linux. And a key feature of Conda is that it is a language agnostic, which means that it can be used to build and manage software of any type from any computer coding language. Now, there's two ways you can get started working in Conda, either by downloading Anaconda or Mini Conda. So Anaconda comes with over 250 data science packages, everything you could possibly imagine to conduct your analyses. And you can think of it as almost the hardware store of data science tools. On the other hand, Mini Conda comes with only a handful of what's needed. So it's more like a workbench with the bare necessities that you can customize with the tools that you want. And then Conda is sort of the assistant that's underlying both Anaconda and Mini Conda, and it helps you organize all of these tools and as well as order new ones when you need them. So to get quick access to working in Conda, it's commonly recommended to install Mini Conda, and that's what I've provided instructions for in the workshop materials that were sent out to participants. So why use Conda? Well, for one, Conda simplifies installation and management of packages, allowing users with limited bioinformatics experience to install packages with relative ease. So before Conda, I found installing packages to be complicated and confusing, and I typically had this facial expression when attempting to install packages from source. Now with Conda, most packages, including all the additional packages they require to run, referred to as dependencies, can be simultaneously installed with a single line of code, making it much more straightforward and pretty easy breezy if you ask me. Now, Conda also promotes reproducibility, as packages required to accomplish a specific task are contained in the same environment, which can be shared with other users who may be working on the same project or want to accomplish a similar task. And we'll be touching on both of these in the workshop. So let's get started. So once you've had Mini Conda installed, the first step to getting started working in Conda is to open a terminal. Now that can be Bitbuys, it can be Ubuntu, it can be just the regular plain old terminal or some other variety. Now again, I just want to remind participants that instructions for installing Conda were sent out as part of the workshop documents. And I also want to mention that if you are following along with today's workshop, please be aware that copying and pasting the commands from the workshop documents directly into the terminal can cause errors, especially for commands containing quotes. So to really immerse yourself in the learning process and become more acquainted with the syntax of Conda commands, I highly recommend typing the commands directly in the terminal. So when working in Conda for the first time, it's important to make sure the software installed properly, and this can be achieved by running one of two commands. So the first command is conda -- version, and this will display the Conda version in the terminal if Conda has installed properly. So in this example, I've installed Conda version 4.10.3. Now, alternatively, you can verify the Conda installation by running conda info. Now this will print all information regarding the current Conda installation, including the version number, as well as the location of where your environments are stored. So now that we've verified our Conda install has worked, the next step is to see what Conda commands are available to us. Now to see these commands, you would type conda --help in the terminal and press enter. Now in the terminal, a number of commands will appear and are available for you to use, including a set of core commands, which I've listed here, that we will touch on throughout today's workshop. Now, if you want to obtain information on how to run a specific Conda command, you would type conda, followed by your command of interest, and then of course the --help. Now, in this example, I want to know a bit more about the create command. So to do so, I would type conda create --help in the terminal and press enter. Now in the window, you'll see a new set of options pop up that are specific to the conda create command, as well as what the command does. In this case, conda create is used to create a new conda environment, and also an example of the basic structure of how to use the command. So to keep projects and workflows organized, Conda allows you to create separate environments containing packages and their dependencies, which are the tools the package requires to run properly. And this can be extremely useful as different packages may contain conflicting requirements, which would prevent you from running them in the same environment. So you can think of a Conda environment as a directory that contains a specific collection of Conda packages that have been installed, while a package or a tool is a piece of code that someone else has written for a specific purpose. Now, to list all the Conda environments that have been installed and are available to you, you would type conda env list in the terminal. Now, if you recently installed Conda, you probably won't have any other environments other than base, which is the default environment, and your terminal will probably look pretty similar to this image. Now, if you have access to the high performance computing cluster at the National Microbiology Laboratory, you will have access to quite a bit of Conda environments, the majority of which are probably located in the shared P drive, and these have been installed by system administrators. Now, another helpful tip is that when you run conda env list, an asterisk will appear beside the active environment. Now you can see in both cases, my base environment is the active environment. So now that you have a general idea of what Conda is, I'm going to show you how to create a new Conda environment and install a package. But before we can do that, we need to know how to search for a package. And the easiest way to do this is to use the Anaconda Cloud, which is an online repository for Conda packages and is located at the following link. So when you click on the link, the main window will appear where you can type the name of the package that you're looking for. So when searching for a package, make sure you are using the correct spelling because the repository does not have autocorrect capabilities. Now, in the example shown in the slide, I'm searching for the package NCBI Genome Download. And this is a really great package because it allows users to easily download sequence files from the National Center for Biotechnology Information, or more commonly referred to as NCBI. So after pressing enter, I can see that my search has returned a single package, NCBI Genome Download, which is stored in the BioConda channel. Now, to get more details, I would click on the package name, and a new window will open, which contains links to additional web pages that provide details on how to use the tool, as well as the code on how to install the tool, which I've indicated here in a red box. Now, this command will install the most recent version of the package, which is available from the BioConda channel. So when installing packages, you typically only want to install from well-trusted sources, and these would include BioConda and Conda Forge. So BioConda specializes in bioinformatics software, while Conda Forge is more of a community-driven effort that provides a wider range of software. Now, an alternative way to search for packages is directly from the terminal using the conda search command followed by your package of interest. Now, this search strategy is extremely useful for displaying all the versions associated with a specific package. So in the example shown in the slide, I want to see all versions that are available for the NCBI genome download package. Now, when you run this command, all available versions will load, as well as 4 columns. So you'll see name, version, build, and channel. So the name corresponds to the name of the package. Version is the version number of the package. Build is the Python version the package is made for, and channel is the location where the package is stored. Now, if this is blank, that means that the package is found in the default channel. But for this introductory workshop, I'm not going to go into too many details about these features, but what you should keep in mind is that there may come a point in time where you may require a specific version and or build number for a package, and this is where you would find that information. So now that we know how to search for packages, the next step is to create a new Conda environment and install that package. And this can be achieved in 2 different ways. So the first way is to create a new Conda environment, then install the package. So this is done in 2 steps, or we can create a new Conda environment and install the package at the same time in a single step. So I've included some helpful tips for creating environments. So make sure you create a new Conda environment for each package to avoid dependency conflicts. When naming your Conda environment, be kind to your future self and choose something descriptive. Typically, Conda environments are named after the package that is installed, and just make sure you're not using any special characters or spaces in your environment name. As I pointed out earlier, when you begin using Conda, you will already have a default environment named base. However, you don't want to install any packages in your base environment. And for participants who have access to Waffles, although you can use shared Conda environments, you do not have permission to modify these environments in any way, and that includes installing packages. So to create a new Conda environment, the Conda create command is used along with the -y and -n options, followed by your environment name. So the -y means to create the environment without asking for confirmation, and the -n indicates the name we want to give to our Conda environment, and of course, env name would represent our environment name. Now you'll notice I have 2 commands listed. So I have here a basic command, which is how the command is run, and then I have a SLURM command. Now, just for context, the SLURM command is for participants who have access to the high performance computing cluster at the NML, otherwise known as Waffles. Now, because this workshop is intended to teach participants how to work in Conda regardless of whether you have access to high performance computing or not, I'm not going to be going into specific details regarding the SLURM command. However, I have provided important information regarding this command in the workshop materials. And because it's extremely important that participants who have access to Waffles use this command when submitting jobs to the cluster, it's really important that you review the information in the workshop materials before working in Conda. So in this example shown in the slide, I am creating a new Conda environment called Conda Workshop. Notice how I use the underscore to separate the 2 words and avoided using a space. Now, for those running the basic commands on your personal device, the job will actively run in the terminal. So you'll see it running as it progresses, compared to those who are going to be running the SLURM command, where the job will be run in the background. So now that we've created the environment, the next step is to verify that the Conda environment was actually created. Now, this can be done by typing the command conda env list in the terminal. And what it'll do is will list all the Conda environments that have been created. So for those who may have lots of environments, it may not be as obvious as to whether the environment has been created. So there is an alternative command that you can use. So you'd use conda env list followed by grep. And this is just a really useful search function that allows you to search for the environment directly by name. Now, in both cases, you can see here that my Conda workshop environment has been successfully created. Now, our next step is to explore the newly created environment. But to do this, we first have to activate the environment. This can be achieved using source activate, followed by the environment name, or you may have to use conda activate, followed by the environment name. And this will depend on how Conda was set up during the initial installation. And just as an FYI, you'll know right away which command you'll need to use because an error message will appear in the terminal letting you know what command is needed. So once the environment has been successfully activated, a prompt will appear beside your username displaying the activated environment. So in this example shown in the slide, I can see that my Conda workshop environment is activated because it appears beside my username. Now, to check the contents of the newly created environment, the Conda list command can be used. In this example, I am listing the contents of my Conda workshop environment. Now you'll notice that it's empty, but that's what we would expect because all we have done so far is create our environment. Now we can proceed to installing the package. So using the information we got from the online repository, we can install our package using the conda install command, along with the -y and -c options. So as a reminder, the -y is used to tell Conda to proceed with the installation without asking for confirmation to the install additional dependencies, because we trust Conda, we're going to let it do its thing. And then the -c is used to indicate the channel name, so where the package is stored, and then of course package name corresponds to the package that you want to install. Now, in the example depicted in the slide, I'm installing the NCBI genome download package using the basic command as well as the SLURM command. Just as a reminder, running the command in your personal device will actively show the job running in the terminal, while using the SLURM command, it'll be running in the background. Now, just some helpful tips when installing packages: make sure the desired environment has been activated. And again, as a reminder, that will appear in rounded brackets beside your username. So to verify the package installed properly, you can run conda list command again. And in this example, I'm listing the contents of my active conda environment, which is Conda Workshop, where you can see here that the NCBI genome download package version 0.3.1 from the BioConda channel has been successfully installed. Now, an alternative way to create environments and install packages is to do it with a single command using conda create, along with similar options that we used in the previous example. So the example shown in the slide, I'm using the conda create command to create a new environment called Conda Workshop, while at the same time installing the NCBI genome download package from the BioConda channel. So to verify the environment has been created and the package successfully installed, we would first activate the environment. Again, this can be achieved either using source activate followed by the environment name, or conda activate followed by the environment name. And again, this will depend on how Conda was set up during the installation. So in the example shown in the slide, I'm activating the Conda Workshop environment using conda activate. And you can see that the environment is now active because the name appears beside my username in the terminal. Now, to ensure the NCBI genome download package has been installed, we can list the contents of the environment using the conda list command. Now, in the example, I'm listing the contents of my Conda Workshop environment, and I can see that the NCBI genome download package version 0.3.1 from the BioConda channel has been successfully installed. So now that we know how to create environments, install packages, and activate environments, how do we switch between Conda environments? So to start working in a different Conda environment, you must first deactivate the current environment and then activate the new one. And this can be achieved using two steps. So first, we'll deactivate the active Conda environment by typing conda deactivate in the terminal. Now, in this example shown in the slide, I am deactivating the Conda Workshop environment. When the environment is deactivated, the name will no longer appear beside your username in the terminal. Now I can activate the environment I want to work in using either source activate followed by the environment name, or conda activate. Now, in this example, I am activating the shovel conda environment, which now appears beside my username in the terminal, indicating that it is active. So depending on your analysis, you may need to install a particular version number of a package. And this is achieved using the conda install command, which we have previously used for installing packages in conda environments. However, This time we are specifically indicating the version number that we want. Now, in the example shown in the slide, I'm installing the NCBI genome download package version number 0.2.12 in the Conda workshop environment. To confirm the desired package version has been installed in the active environment, we can list the contents of the Conda environment by running conda list. Now, the example shown in this slide where I'm listing the contents of my Conda workshop environment, you can see here that the NCBI genome download package version 0.2.12 has been successfully installed in the environment. Just as a helpful tip, when installing packages, always make sure you have the correct environment activated. Now, sometimes we change our mind and we want to make sure, we're running the most current version of the package. So to do this, you can use the conda update command. Now, once the package, this will always download the most recent version of the package in the active conda environment. So once the package has finished updating, what you can do is you can run conda list again to verify that the package has been updated accordingly. So in the example shown in the slide, you can see here that I've updated my NCBI genome download package to the most recent version using conda update. And then when I list the contents of my conda workshop environment, I can see that it has changed from the previous example from version 0.2.12 to 0.3.1. And of course, as with anything, make sure when you're updating conda packages that you have the correct environment activated. Now, as I mentioned earlier, reproducibility is really a key objective of conda. So it's really important that we can reconstruct the same environment on a different computer and across operating systems without any issues. Sharing a project environment across platforms can be achieved using the export option to create an environment.yml file, which is essentially a configuration file that we can share with others that provides the necessary instructions for them to create a similar conda environment on their computer. Now, to ensure the environment.yml file can generate environments across different operating systems, we have to use the -- from history option. Now, what this does is it only includes packages that you have specifically asked to install in your environment, as opposed to including every package in your environment, which may not be compatible across operating systems. So after running the command, the environment.yml file will be saved to the current working directory. Now, in the example shown in the slide for both the basic and SLURM command, I'm exporting the information to build the conda workshop environment to the environment.yml file. So now that I've created my environment.yml file, I can share it with others who can use it to then recreate the same environment on their computer using the conda env create command. And here's just an example of what the environment.yml file looks like. So when using the conda env create command, I also have to use the -f option, which indicates that we want to create an environment from the specified file, which in this case is our environment.yml file. Now, in the example shown in the slide, I am creating a new environment from the environment.yml file, which is saved in my current working directory, and my current working directory is displayed in the square brackets beside my username. Now, in the SLURM command below, I'm running the exact same command. However, my current working directory is now project Jill Rumore. So in the conda env create script, I have to show the command where the environment.yml file is by navigating it to it through the directories till I reach the conda workshop directory where it is saved. And just always make sure before creating environments from .yml files, always make sure that no environments are active. Now, if you decide you no longer want to use a certain package, you have the ability to remove it from the environment using the conda remove command. Now, the command is similar to uninstalling a package, so it cannot be undone. The conda remove command will also, in addition to removing the specified package, the conda remove command will also remove any package that depends on the package that you're removing. So in the example shown in the slide for both, again, the basic and the SLURM command, I'm removing the NCBI genome download package from the conda workshop environment. To verify the package has been successfully removed, you can list the contents of the active environment from which the package was removed using conda list. In this example, we can see that the NCBI genome download package is no longer present in the conda workshop environment. And again, as a helpful tip, just make sure you have the correct environment activated before removing packages. Like removing packages, you also have the ability to remove environments. And again, this cannot be undone. So it is highly recommended to first do a dry run. And this is particularly important because environments can be quite elaborate and they can contain a number of different packages. So to do a dry run, this can be achieved by running the conda env remove command with the -d option. Now, in the example shown in the slide, the command shows that it will remove the conda workshop environment without actually doing it. So it's a great way to verify that what you're asking for is really what you want. So to permanently remove the environment, you would rerun the script without the -d option, and you would include the -y option. Now, in the example shown in the slide, I'm removing the conda workshop environment. And you always want to make sure that when you're removing environments, that all your conda environments are deactivated, and always make sure you're doing a dry run. And this is just to save yourself from a major headache of removing the incorrect environment and having to reinstall everything all over again. So what you can do also is once you've removed the environment, if you want to verify it was removed, you can do that by running conda env list, or you can search for the environment using conda env list followed by that grep search function. And that's if you have quite a few environments to search for. So if the environment's successfully been removed, you will no longer see it in your environment list. And also when you search for it, no search results will be returned. All right, so now that we've gone through what conda is, how to navigate it, and run the core commands, I'm going to show you how you can approach running a package that has already been installed in a conda environment. It can generally be achieved following these few steps. So the first step towards running a package in conda is to have a basic idea of what it is you'd like to accomplish. And of course, this is going to be based on what package you've chosen to install. So for example, I previously chose to install the NCBI genome download package because I want to download the complete genome in FASTA format for Helicobacter pylori reference strain 26695 from NCBI's reference sequence archive, or more commonly referred to as RefSeq. Now, the next step is to review the tool documentation to see how I can actually accomplish this task. And this information can be obtained from the Anaconda Cloud by clicking on that GitHub link in the section of the information on how to use the tool. Now, this will take you to the online tool documentation where you can scroll through the documentation until you come across some information that may be of use to you. So as I scrolled through the information, I came across instructions for how to download reference sequence or genomes in FASTA format, as well as how to download complete genomes, and how to download genomes corresponding to a specific tax ID. So it looks to me like I'm going to have to include a few different options in my code to achieve my task. Now, in the documentation, you will also commonly find a help command, which can be run in the terminal to give you a more thorough overview of all the options the tool has to offer. And it's extremely useful in helping you to become more familiarized with using the tool. And I highly recommend doing this. So once we reviewed our tool documentation, the next step is to activate the environment containing the package you want to run, which in this example is my conda workshop environment, because that's where I installed my NCBI genome download package. Now, I decided I want to get a bit more familiarized with all the options the tool has to offer. So the next thing I do is I run that NCBI genome download help command. Now, in addition to the usage statement, which again is the basic structure of how you would run the command, you can also see that the package has an extensive list of options. Now, to accomplish my task, which just as a reminder, I want to download some sequence data from RefSeq, I need to make sure that I include a number of key options in my script. Now, one of them is formats. And this is because I want to make sure that I'm downloading my sequence data in FASTA format. The next option I want to include is assembly levels. And this is to indicate I want to download the complete genome. And then I also want to include the option tax IDs. And this is to indicate the taxonomic identifier that corresponds to my organism of interest, which is Helicobacter pylori reference strain 26695. Now, I also have to include the taxonomic group, which in my case is bacteria. Now, this is just sort of as an FYI, that groups is a positional argument, meaning it matters where it appears in the code. So if we look at this usage statement, we can see that it appears at the end. So when I'm writing my code, I have to have this particular option at the very end of my code. Now, one thing you'll notice is I'm not concerned with including the section option in my script, which from the tool documentation tells the package what repository to download from, so GenBank versus RefSeq. Now, I'm not including it because it tells me that the package will download from the default repository RefSeq, and this is exactly what I want to do. So to avoid complicating my code, I'm going to leave that option out. So now that I've activated my environment and thoroughly reviewed the tool documentation to get the options that I need, the next step is to create a project directory where results can be saved. Now, since navigating the command line and creating directories was covered in last week's Introduction to Bash workshop, I'm only going to provide a brief overview of the steps to create a directory today. However, as part of the workshop materials, I have included some supplementary information on how to create directories. As well, Grace has kindly allowed me to share her Bash cheat sheet that she created for the Introduction to Bash workshop that was held last week. So in the example shown in the slide, I'm navigating from my home directory, which is indicated by the tilde beside my name, to the Conda workshop directory, which is located at the following path, and I do this using the cd or change directory command. Now, once I'm in the Conda workshop directory, I make a new directory called NCBI download using the mkdir command. Notice how I avoided the use of spaces and special characters in my directory name. So once my directory is created, I can then change into the new directory using the cd or change directory command. And the NCBI download will now serve as my project directory. Now, my next step is to run the package from the project directory. So in the example shown in the slide, which is again displayed for both the basic command and the SLURM command, I'm using the NCBI genome download command along with the set of options that we discussed in the previous slide to accomplish my task. So again, the formats option tells NCBI genome download tool to download my sequence data in FASTA format, while the assembly levels option indicates that I want the complete genome only. And the tax IDs option corresponds to the specific taxa, 85962, that I want to download, which corresponds to the Helicobacter pylori reference strain. And so the tool knows what taxonomic group to search for, I also need to ensure that I am including bacteria at the end of the script. So once the download has completed, you can verify it ran successfully by navigating to the results directory using the terminal or File Explorer. The more exposure you get to the command line, the better. So I would highly recommend trying from the command line first. Now, in the example shown in the slide, I'm listing the contents of my project directory using the ls command. And again, this is the directory where I ran my package from. Now, in doing so, I can see that a new directory called refseq has been created. I then change into the refseq directory using the cd command and list the contents to see what is available. In doing so, I can see that a new directory called bacteria has been created. I then change into the bacteria directory using the cd command and again list the contents. I can see here that I have 2 sequence directories corresponding to the Helicobacter reference genomes that I have downloaded. Now, I want to make sure that these directories contain sequence data in FASTA format, which is what I had requested from the tool. So to do this, I then move into one of the directories using the cd command and list the contents. So I can see here that a FASTA file has been downloaded, and that's indicated by the .fna extension. However, I can also see that the file is compressed, and that's indicated by the .gz ending, which corresponds to gzip. Just as an FYI, when downloading sequence data, the file will usually be compressed, and this is just to speed up the download process. However, most tools, downstream tools, can't use compressed files, so it's always a good idea to uncompress it. Now, the command you use to uncompress a file will depend on the file extension. Now, because I won't be going into too much detail about this, I have included a resource in the helpful resources slide at the end of the workshop, where you can check it out to get more information regarding how to uncompress different types of files that you may encounter in doing your analyses. So in this particular example, my file is gzipped, so I would use gunzip to uncompress it. So once I do that, I can list the contents of the directory to make sure that the file has been successfully uncompressed, and it has, because it no longer has the .gz extension. And I just want to point out, when you're running commands to uncompress files, especially using waffles, it's very important that you do use the SLURM workload manager, especially for very large files, because it can take up a lot of resources. So here's an opportunity for you to try it on your own. After the workshop, I want you to try and apply what you've learned today to create a new Conda environment, install a package of your choosing, preferably something that might be useful to your own data analysis, and then try running the package using the documentation for guidance. Really, the best way to learn is to immerse yourself in the learning process and try it on your own. So before we conclude today's workshop, I just want to share a few final thoughts from my own experiences. Learning computer coding requires a lot of patience, practice, and dedication. Try to use as much as you can in your daily activities so you can stay sharp and don't lose the skills you've learned. I can attest to the fact that stepping away from computer coding for months at a time and then trying to get back into it is extremely challenging, and it almost feels like you're starting from square one each time. Don't be afraid to make mistakes, because nobody learns from being perfect. Trust me. I mean, I've made a ton of mistakes throughout my computer coding journey, and even to this day, I still make mistakes, but it has really been a fundamental part of the learning process. And if you're ever unsure about something, ask questions from someone who's already learned it, or even Google it. There are a ton of forums on the internet that are dedicated to help solve computer coding problems. And chances are someone's already posted a similar issue. And most importantly, be kind to your future self. Make sure to take good notes throughout the entire process, because at some point you're going to do something really awesome and you'll want to recreate it. And you certainly don't want to sit there wasting time asking yourself, how did I do that again? So last but not least, I've included a list of resources that I hope will be of use to you as you navigate the waters of working in Conda. Thank you to all participants for attending, and I hope today's workshop has provided you with a solid foundation to get started working in Conda. And of course, I wish you well on your coding journey. Thank you.